In computing, selection is a vital feature of program flow that allows programs to make decisions and execute different blocks of code based on specific conditions. This ability to branch into different paths is essential for creating flexible and dynamic programs that respond to varying inputs or situations. Selection is most commonly implemented using if statements, which evaluate conditions and determine which set of instructions to follow. If statements can range from simple structures to more complex forms, such as if-then-else, if-else-if, and nested-if statements, each suited to different programming needs. The if-then-else structure is the most basic form of decision-making in programming. It begins by evaluating a condition, which is an expression that resolves to either true or false. If the condition is true, the program executes the code in the then block. If the condition is false, the program moves to the else block and executes that code instead. For example, in a program designed to determine whether a student has passed an exam, the condition might check if the student's score is greater than or equal to the passing mark. If the condition is true, the program could output a message such as, "Congratulations, you passed." Otherwise, it might output, "Unfortunately, you did not pass." The if-then-else structure is straightforward and widely used for situations where a single condition needs to decide between two outcomes. When a program needs to evaluate multiple conditions, if-else-if statements become useful. This structure extends the basic if-then-else by allowing the program to check additional conditions if the first condition is false. Each else-if block contains a new condition to evaluate, providing multiple branches for the program to choose from. For instance, in a program that assigns grades based on exam scores, the first condition might check if the score is 90 or above to assign an A grade. If that condition is false, the else-if blocks could then check if the score is 80 or above for a B, 70 or above for a C, and so on. If none of the conditions are true, the program might default to the else block to assign an F. This approach ensures that only one block of code is executed, corresponding to the first true condition, making it both efficient and easy to follow. Nested if statements take decision-making a step further by placing one if statement inside another. This allows programs to evaluate conditions within conditions, enabling highly specific and hierarchical decision-making. For example, in a program that calculates shipping costs based on both weight and destination, the outer if statement might first check if the package is under 2 kilograms. Within this block, a nested if statement could then check if the destination is local or international to apply the appropriate cost. If the package is not under 2 kilograms, the outer else block could handle heavier packages with its own nested conditions. Nested if statements are particularly useful when decisions depend on multiple layers of criteria, but they must be used carefully to avoid excessive complexity, which can make the code harder to read and maintain. Selection, through the use of if statements, allows programs to adapt their behavior based on varying conditions. The if-then-else structure provides a simple yet powerful way to handle binary decisions, while if-else-if statements add flexibility by allowing multiple conditions to be checked. Nested if statements enable detailed and hierarchical logic, making them suitable for more complex scenarios. Together, these techniques form the foundation for conditional decision-making in programming, enabling developers to create dynamic, responsive, and intelligent systems. Mastering the use of selection is essential for writing effective code and solving real-world problems with precision and adaptability.